But we're talking about the Mars landing right now. Perseverance landed, which is awesome, right? And then I think Caleb, what were you mentioning there?
I think was it this rover? Was it this um mission that included like a drone that they plan to observe the red planet from above?
Yes.
I think it was.
Yeah, I
What was it called?
believe that's accurate.
All right, sorry, I'm back and paying attention here. It looks like
There you go.
my audio is set up now. Hopefully everyone can hear me now. Sorry about that, but I'm Dana Thompson, the director here. We were talking about that Mars rover landing this week on the Red Planet. And Greg, thanks so much for taking control there. All right, so we're gonna see a simulation of the landing. And again, this is just a simulation. This is an actual video, but this is what it would be like. So Caleb, go ahead with your question again. I missed it.
I was wondering, was this the Mars mission, the Mars rover that was going to include a drone to observe the red planet? Or was that
Yeah, it's like a helicopter, a little helicopter called Ingenuity. So the Mars 2020 rover is called Perseverance, or you can call him or it Percy. So Percy landed and it brought along a friend, Ingenuity, a little helicopter drone thing. It's about 4 pounds and it's going to just be a technology demonstration, which just means that they're trying to figure out if we can fly something like Ingenuity, like a drone on the red planet. But let's go ahead and pause it about midway here and talk more about the landing process. So yeah, this whole mission, it brought along a lot of different science experiments. It's a whole science laboratory, and it lands with the help of a parachute. Mars does have an atmosphere. It has an atmosphere about 100 times thinner than ours, and so that parachute needs to be specially designed for that environment. And it lands this craft here. So the rover is inside this. This originally had a heat shield that popped off, and we'll see the rover in just a few. All right. Oh, there goes the heat shield. There it is. All right, so here's the rover. It's still attached to something else that's helping it land in a very exact location in this crater. So I mentioned that there's this crater. It used to be a riverbed where life might have existed at one point on the red planet.
Mhm.
And the crater, it looks like it might be pronounced Jezero, but it's actually pronounced Yezero. Yezero with a Y sound. So the Mars 2020 rover is landing in Yezero crater here with the help of that device there, which we call a sky crane. And after the sky crane lands the rover on Mars, it flies away to a safe distance just to crash. So it did its job and it just crashes. So it's a lot of effort put into something that will eventually just crash.
So it's a good sacrifice.
Yeah. So like, why fly so far away from the rover first? So the rover and the area doesn't get disturbed, right?
Mhm.
But let's back up just a little bit, crew, because I want you to try to figure out some things here. So here's the sky crane. And we have the thrusters here kind of hovering it down to its location. Do you know how we landed other rovers on Mars before we had the sky crane technology?
Wasn't there one where when it got close enough, it like deployed like it kind of like a like I guess kind of we're kind of like it bounced along the surface?
Yes. Yeah. There's a bouncing system that they used. It was basically a whole bunch of airbags that surrounded the rover Spirit and Opportunity. So Spirit and Opportunity were surrounded by a whole bunch of airbags, and when it dropped, it bounced and bounced because of those airbags. And once it stopped bouncing, eventually, it bounced for like a long time. It rolled for a very, very long time. So it wasn't really accurate of where it was going to land. They didn't know exactly where it should land because of that bouncing and that rolling. But the sky crane helps it land in a very specific location. And also, airbags just wouldn't work for something of this size. The size that Percy is, and the size that the previous rover that was landed with the sky crane technology was as well. That was Curiosity. But why use these like cords here to lower the rover down from the sky crane?
Well,
Why does it
I-
need to be separated like that? Why do you think? If you're watching and you have a guess, you can put it in the chat. But Nicolette, what's your thoughts?
Well, I'm worried that if you just drop it and you have nothing like suspension. My sister bought a bike a long time ago, a mountain bike that has suspensions on it because it's a mountain bike. But since it doesn't have that, you'd be worried that like a tire would break, or sometimes something this complex could have something very small that could snap on the inside. So you'd want the strings to hold it so that you can gently place it.
Yeah, but like the sky crane could come down with it and be really close to the ground and just kind of let it go safely here. But it would
How-
be. Go ahead, Greg.
How long are the cords?
Long enough so that this from the thrusters here doesn't interact too much with the ground.
I mean,
'Cause-
that's what I would assume,
yeah,
right?
'cause,
So
yeah.
you don't want to disturb the ground underneath it. So if the entire goal is to not disturb the area that surrounds it, that would be my guess as to why they lowered it. with
Yep,
the,
absolutely, because there is some
cords.
disturbance there, but they don't want too much, and yeah.
What is it? What is its main mission? What is it supposed to find?
It's looking for evidence of
do-
life. It does have another technology demonstration though, a really cool one called Moxie. So Moxie is looking to produce oxygen, looking to produce oxygen from carbon dioxide. Mars's atmosphere is mostly CO2, carbon dioxide, and they're looking to convert that using Moxie to oxygen to maybe help with future human exploration of Mars.
I thought we talked about a while back another rover that was going to have this cute little dome that it would take out, and it was looking for Mars quakes. If that's the right technical
Mars
term.
quakes, yeah. It was
Marsquake.
InSight. It was a lander on Mars. Landed a couple years ago.
Okay. Oh, okay.
And it's looking for Mars quakes. Yeah, we talked about InSight last semester. Percy weighs over 2,000 pounds, by the way. So it's pretty hefty.
But I thought things were supposed to be light because the heavier it is, the more it costs to put into space.
But that is true. But we really, if you're going to send something to Mars, you're going to do it right. So there's Yezero
How long did it take
crater
to get there?
About 2 years. It
Oh,
takes
sorry.
about 2 years. I'm sorry. It takes about 7 months, to get to Mars. And that window opens every 2 years or so. So there's only a specific window for sending things to the red planet, which is why there are 2 other missions that pretty much arrived at Mars the same time, so to speak, same week anyway. There are 2 orbiters that went into orbit around Mars from other countries. So that's pretty cool.
Where are they from? Wasn't it one from like one was from, was it China?
Yeah, one was from China. Does anyone remember the other one?
That's a great question.
The United Arab Emirates? Saying that?
Ah,
Yep.
yeah.
It was their first mission there.
Oh.
It was both were successful too. So Mars got
Mhm.
2 new kind of moons or not natural satellites, but man-made or human-made satellites.
Yeah. I have so many friends to play with now.
Yeah, there's a lot of friends there. Nicola, you're just a little quiet for me.
Oh. Okay, it's probably me being quiet as a person. I can speak louder.
Sounds good. We're looking at our sky here now. We're back on Earth. Of course, that W and SW is not in our sky, but that's in our simulation here just to help us remember what directions we're facing. We were looking down on campus here at Ball State University, and we're changing our view to look south because that's where all the constellations we've really been exploring are after sunset. So let's have the sunset in our simulation here.
Some interesting cloud cover, at least.
Yeah. Thanks, I programmed that out. I spent a lot of time on those clouds. Spent a lot of time on those clouds and the manipulation of them in our software that we use.
Looks good.
Hi, Moon.
Yeah, we have nice system here. All right, so we're facing south. I know the S might be cut off for some people, but let's go up to our constellations that we'll focus on. And in the wintertime, winter months, you really want to find Orion the Hunter first. It's one of the easier constellations to find, and then use it as a guide to find everything else. And if you've been following along with us during the Constellation Crew program, you know that we've explored Orion the Hunter and have used him to help us find Taurus the Bull, Auriga the Charioteer, and we're going to use it to find our constellation that we're exploring this week, Gemini the Twins. So there's Orion there. And again, you can use Orion to find lots of other constellations and objects in the sky. So let's zoom up and see the ones that we've been exploring. If you follow Orion's belt up, you can find Taurus the Bull. Let's show a line here. Using Orion's belt, going up away from the ground, you get to Taurus, and then you also get to this little tiny cluster of stars. Crew, what's that called?
The Pleiades.
The Pleiades.
The Pleiades, the Seven Sisters. Tonight, if the sky is clear, you can see our first quarter moon there. We also have the two constellations that just came up. We have Auriga up here and Gemini the Twins, which is the constellation we're really going to be focusing on. So it's a pattern of stars in our sky, one of the 88 constellations. And it has two bright stars up here that we're going to explore. But before we go and explore the stars in it, you might know about Gemini for a few reasons. One of them being these streaks here. And what are those streaks, Nicolette?
So those streaks are meteors for a meteor shower. We'll dive a little bit deeper on what that exactly means, because there are different types. There's meteors, meteoroids, and meteorites. But certain constellations have meteor showers that appear in them. So that is why they usually have a name. And please correct me on pronunciation. Geminids.
The Geminid meteor shower, yeah, so the Geminids.
Which happens in December, so we have a little ways away before that comes around. But meteors come from space. They are space rocks that enter Earth's atmosphere, and it gets a little complex with the science on how exactly the meteor heats up, but it has to do with the space rock interacting with Earth's atmosphere, and eventually it creates those streaks that you're seeing, which are very beautiful. You can also call them shooting stars, but as you'll know, they're not actually stars, they're meteors. So you'll see here you have your different definitions. A meteor is a space rock that has entered Earth's atmosphere. A meteorite is a space rock that has passed Earth's atmosphere and survived. That's the key point. Most of the time, meteors do not survive that long and make it past the atmosphere in order to hit Earth. And then a meteoroid is just a giant rock, or not as big as an asteroid, but it's a decent sized boulder rock. You could
like maybe like a pebble or so,
or that,
or larger, yeah.
Mm-hmm.
Like a large pebble, yeah.
Yeah. So the question comes, where do they really come from? I was very confused. I was always under the assumption, learning it when I was really little, that meteors come from the asteroid belt. They just get pulled in somehow and they fly into our atmosphere. That's always what I was told when I was young. But the more popular way, and I guess the correct way, because I'm not sure if meteors can actually travel that far to Earth, is that a comet, who is under the influence of the sun's gravitational pull, orbits and eventually comes to the sun, and it gets close enough where it'll heat it up really nice and toasty, and bits of ice and rock will come off of it. And eventually we'll get into the way of Earth's orbital path, and we'll kind of like orbit around and smack into them.
Yeah, so comets come close to the sun, sometimes get warmed up and start to leave bits behind.
Exactly.
And when Earth orbits into those little bits, we can have meteor showers like the Geminids in mid-December. There's about what? You can see maybe one every minute, right?
Mm-hmm.
One every
Yeah, I
minute.
believe
Wow.
so. For this
We're
one.
speeding it up quite a bit here. We're doing about one every second here rather than one every minute. So if you go outside during a meteor shower and you get really excited and expect to see something like what we're showing here, or maybe something like fireworks, you're going to be a little underwhelmed because it's not going to look like that. But if you are patient and you catch a really great one, it is worth the wait.
Yes.
Yeah, usually it's more like this. You might see one. Usually you just have to wait a long, long time. But
Do
you
you
can...
see?
What?
Do you see anything?
No. But we do see the star here that I just highlighted. That star is Pollux, one of the stars of Gemini. All right, so we pointed out Gemini here, this kind of rectangle shape in the stars. It's above Orion the Hunter. So if you can find Orion and go up from his belt, you can reach that rectangle in the sky. Gemini's popular for another reason. Why is that, crew? Not because of the star here, not because of the meteors. What is special about Gemini? What is
Part of the zodiac?
Yeah, it's a part of the zodiac. Gemini is one of the 12 zodiac constellations, and we do actually use the zodiac in astronomy, right? The path that the sun makes in our sky, or the apparent path the sun makes in our sky throughout the whole year, follows along it goes along a specific path, and all the constellations that are in that path are called the zodiac. So one of the 12 zodiac signs is Gemini. And we have two stars up here that mark the heads of the twins. So remember, Gemini is the twins. We have the star Castor on the west side, and then Pollux on the east. And we're going to take a trip to see Pollux and see what's around there. And I think, Caleb, you have some great information about what's going on there. But,
Yes, we do.
yeah,
Yes, we do.
Yeah.
So
Go ahead.
So we zoom a little here. We actually something that's pretty interesting. Pollux is a star that is in the later stages of its life, particularly the red giant phase. And if we come closer to Pollux, we can see something very special. An exoplanet that was discovered, I think, relatively recently. I think in the last 10 years, known as I think it's called Pollux B. So, yeah. So this is.
Yeah, we're going to zoom into Pollux here, and the exoplanets are the planets going around other stars in our galaxy. They're just kind of named based on the host star.
Yeah.
So we have Pollux in the middle. That is a star. And then this is the orbital line or orbit for the exoplanet here, Beta Gem B. Beta Gem is another name for Pollux. And what's the beta mean, Caleb? You found something interesting about that.
Yeah, actually, I found something very interesting. The relatively modern method of classifying stars and constellations was classifying stars usually by their magnitude, by their brightness, usually you go by the Greek letters. So alpha is usually the brightest star in the constellation, and then beta, and then the next few letters on the line. But actually, what's interesting is that Pollux is actually the brightest star in Gemini, not the second brightest. Yes. And yet it's still given the designation of Beta Gem.
Yeah. So Pollux is also called Beta Gem or Beta Geminorum. And the beta should mean, due to the way that it's all stars are classified and everything and named, it really should mean that it's the second brightest star in Gemini, but it is the brightest, which is pretty cool. And also very confusing.
Yeah.
But I guess they don't want to
I
rename it because it's probably in a lot of publications and research articles.
I did look up a little bit, and I did find that it's the rules aren't necessarily strict for the method used to classify stars, so it's not exactly as strict as it could be. So
Yeah. We're gonna look at
so
Alpha
the X
Gem too, in just a bit. But yeah, what do we have about this exoplanet, and what's this green ring?
This green ring, if I remember correctly, is the habitable zone of the star. Here. That's basically what some scientists will call the Goldilocks zone. Where it's the right conditions for life, for a planet with life to form around the star. So our Earth is in that habitable zone of our own star. And this here is the habitable zone of Pollux.
Yeah.
Did we mention what type of planet Beta Gem B is?
Oh yes, this is actually a gas giant,
Okay.
and it's about twice as massive as Jupiter. Jupiter is, and it's a little farther away from its own star as Mars is to our sun. So
Interesting.
Yeah, so
What
it's
kind
a
of fact-
hot Jupiter. It's really a lot closer to the star here than Earth is, or excuse me, than Jupiter is in our solar system. So it's what we call a hot Jupiter. It's really close to that host star. And there's a lot of questions about like why or how can it still be a gas giant planet so close in? It's warm, that gas should really expand and probably not stay together as a planet. So there's a lot of, guesses or hypotheses as to why that might be.
Isn't
if I
there
remember
like
correctly,
a hypothesis that Jupiter originally was a lot closer to the sun?
There is, and that's actually what the Juno space mission is trying to find.
Mhm.
So Juno is a satellite going around Jupiter, and it's trying to find, basically, it's trying to find out how much water is there, and how much water is there will tell you how far it formed away from our sun.
Mm.
The sun formed
just
first in our solar system, and then Jupiter formed next, and then all the
Mhm.
other planets formed. So Jupiter formed out of leftovers of the sun, and all the other planets formed out of leftovers of Jupiter. So we're like leftovers of leftovers here on Earth.
if I remember my facts correctly, I think Jupiter has a very strong magnetic field. Am I correctly? Am I right?
Yeah, it has
That
a
maybe
really
that.
strong one. Yeah.
So if like a gas giant like Pollux B has a strong magnetic field like Jupiter does, that could be a reason why it's not hasn't been blown away.
Yeah.
Mhm.
So
Yeah.
Could be.
But like, why is it in so close as it is? Because some of that material might not, form at that distance from that host star in the early ages of that star system. You know.
yeah,
So
I've
there's a
read
migration hypothesis, and I'm not sure if it's a theory. You have those steps that you have to take to get to a theory, but it might have migrated inward, like what Greg was saying, how Jupiter either migrated inward towards the sun, or migrated outward from the sun in its formation. And finding out how much water it has from that Juno spacecraft will really be able to tell us that, because there's like this thing called a frost line and some other specifics of where water can exist in various forms in our solar system.
quick question: wasn't the first ever discovered exoplanet a hot Jupiter?
There's a lot of like first exoplanets discovered. Oop. Let's go back just a little bit so we don't go too far into the next topic here. But there's a lot of people say it's referred to the first exoplanet found around a sun-like star. A lot of people refer to that one, and I can't remember that one. I think it was Pegasi, Beta Pegasi or something like that. But then there's also the first exoplanet, which I think was found around a pulsar, which is really strange. So there's a lot of different firsts when it comes to exoplanets. It just depends on what technically they mean by first. Is it first to be found? Is it first to be found around a sun-like star or something else?
Wow.
We were just exploring Pollux here, the star in Gemini the Twins, which is part of the rectangle group of stars above Orion the Hunter, which you can see tonight after sunset, if the weather's nice. We got our moon over here. So our first quarter moon, if you go up over, you can get to that rectangle shape, or you can go up from Orion the Hunter. The top two bright stars are Castor here and then Pollux over here. Pollux has an exoplanet going around it, as Caleb told us, and Castor's a whole nother animal. What's up with Castor, Greg?
Yeah, so I know it may not look like it, but this week Caleb and I are twins. So he had Pollux, I've got Castor. Castor normally appears as just one star and was first described by William Herschel in 1803 as a binary star system. But come to find out, Castor is actually 6 stars. So even though it looks only like one, it's actually 6 stars together. And really, technically, it's 3 pairs of binary stars that are all kind of just rotating around a common center of mass, right?
Yeah.
So as you can see from this graphic, which is awesome, Castor A, and B, A are the 2 brightest. They're both A-type stars, which means they're really, really hot. And then the other 4 we refer to as M-type stars, right? They're cooler, right? They're still stars, but you know, they're a little bit cooler.
Yeah, they're less hot than all the other stars are, and they're pretty small too. So we can say M-type or like red dwarf stars as well.
Yep. The whole total mass, and you can actually, the other thing I love about this graphic is that it does compare all of the sizes to our sun. And the whole total mass of all 6 together actually happens to be about 6 times the mass of just our sun.
That just works out great mathematically.
Which is kind of interesting, right?
Yeah.
They range from about half a solar mass to a little over 2 solar masses, which is what Castor A is.
Cool. Okay, so let's see that back in the sky again. Oh, let's see it back in the sky again. There we go. All right, so we had Castor here. That's what Greg was just talking about. Thanks, Greg. And then Pollux over here. So Castor, that one star is actually 6.
So then binary star systems work by the 2 stars orbit around the same center of mass. So then they're doing that, and then all 3 of those systems are orbiting around another same center of mass.
Yes.
So spinning and then spinning.
So this, the pair here. Sorry, Greg. You mentioned it perfectly. That is this pair orbiting around each other, orbiting around a center of mass, and then this pair orbiting around a center of mass, and then this pair orbiting around a center of mass, and then all 3 of them orbiting around a center of mass. So there's lots of physics going on here.
That is a fascinating.
Amazing.
Yeah, astronomers love it.
I'm going gaga over it already. I love it.
And our sun's just the sun. We don't really have a cool system like Castor there. Wish we did.
Yeah.
Some people say that Jupiter could have been our second star. But I'm happy with our one sun. It's cute.
Yeah. But our sun won't be around for forever, right? It's going to turn into a red giant eventually in about 5 billion years. We don't have to worry about it yet. But after that, it will kind of its layers of gas will expand out into space and it will become something that looks like this, maybe. So what is this?
This is what astronomers call a planetary nebula. This is designated as NGC 2392. It did another name, but that name has been discontinued for certain reasons. So, discovered by our good old friend William Herschel. He discovered a lot of stuff. So,
Okay.
Yeah. So this is a star. This, I guess, was a star. That it was somewhere around close to 5,000 light years from Earth, and scientists believe that it is the planetary nebula. It began forming around 10,000 years ago. So, and it's constantly expanding. So.
Yeah, so this is the remains of that dying star in the middle, a white dwarf star. So after our sun dies, it has its core collapses into a white dwarf star, and all of its layers of gas kind of get pushed out. And this isn't, of course, our sun dying. It's another star out in our galaxy, like our sun, that has died already, and it's beautiful. But all of this is in motion, and it's expanding. And maybe the material here that was created by the star, the new elements here, will eventually form other star systems and other planets.
Yeah. Fascinating about astronomy is that we can observe both the past and the future at the same time. We can see what will happen in the universe as well as what has happened.
Yeah.
So.
All right. So there's other nebulae in space. So that was a planetary nebula, and this is another nebula out in space. Very similar, but it looks much different. We actually have two pictures of it. And Greg, whenever you want me to go to the next one, just let me know.
Yeah, so this is the Medusa Nebula. This is actually one of my favorite ones because I just think it looks really cool. So it's got those kind of wisps of gas that you can see in that picture there that for whatever reason people just associate with snakes. And so that's why they call it the Medusa Nebula, right? So the Medusa Nebula is about 1,500 light years away from Earth, so it's a lot farther away from the previous one. And it's pretty massive. It's 4 light years across, which is huge. But that distance between the Earth to the Medusa Nebula actually makes it really difficult to see. Even with telescopes, it still becomes pretty difficult to see as well, just because of that huge distance that it has to travel. And you can head to the next picture. The Medusa Nebula is also a planetary nebula, which Caleb, I know, had talked about before. And just a reminder, planetary nebula really doesn't have anything to do with planets. Early astronomers with basic telescopes just saw these round looking things, and they knew they weren't exactly stars, and so they called them planetary nebula because they kind of looked like planets. They couldn't see this kind of detail. This planetary nebula is just like with Caleb's. There's got a white dwarf in the center, and it's surrounded by gas. So a lot of people have actually looked at the Medusa Nebula as kind of what could happen to our sun, right? So when our sun expands, eventually that gas will that hot gas will expand out and could form something very similar to what we see in the nebula that Caleb talked about, as well as the Medusa Nebula.
Yeah. Do you know how far the Medusa Nebula is?
Like from Earth?
Mm-hmm.
Yeah, it's about 1,500 light years away.
Oh, okay, so not too far.
Yeah.
It's great that we can see some galaxies. This looks like a galaxy that's much, much farther away, of course, outside of our own galaxy, the Milky Way. And then this looks like a galaxy down here too.
Yeah, these pictures are always really cool because I always find new things every time I look at them. I
Yeah.
always find new things that are just really
Over
cool.
here,
Can we
that's probably a
see
galaxy.
the white dwarf left behind?
I don't see evidence of it here. This star is highlighted quite a bit though.
Yeah, this picture makes it kind of difficult to see kind of which one would have been the white dwarf
Yeah.
left behind.
Some of them might just be photo bombing, the picture, getting
Yeah.
in the way. Because space is three-dimensional, right? So,
Yeah.
Right.
Yeah.
I love that.
all right, let's go ahead and keep it going here, wrapping it up with mythology with Nicolette, our kind of reoccurring segment here. So take it away, Nicolette.
It's my favorite segment.
Mine too.
Just so we're clear.
Awesome. So, last week, some of the mythology was very fascinating, and I very much enjoyed it because I was in the chat last week. This week is a little complicated for me. There's a lot going on, so if I start to talk slow, it's to help me get through it because my brain can't go that fast.
Because there's like a lot of drama, right?
Yeah, there's a lot of drama.
Yeah. Which
So
is why we like it.
For those who are really involved in Greek mythology, the town, village, kingdom, Sparta may sound very familiar. I don't know much about Sparta other than the references and how it's like a warrior kingdom, I believe. But it all starts there, and the queen Leda is going to give birth to two sets of twins. Each one, so each set has a boy and a girl, and Castor is one of the twins. He is mortal, and his father is Tenderius. If I'm pronouncing that correctly, he is the king of Sparta at the time with Queen Leda. And then Pollux is the other twin of the other set, and his father is Zeus. So he is not mortal. He is half god or a full god. I'm pretty sure it's half. So those are the two boys who are represented in the Gemini constellation. So they are related half brothers, but they are not twins. They were not in the womb at the same time, which kind of confused me. But they grew up together, surprisingly, and they became very, very close. They were best friends and did practically everything together. They even went on special missions and tried to save people and help their kingdom together. And they were very well known for that. To put the myth a little bit more simply, at some point, Castor gets killed and dies because he's mortal. And Pollux is very upset and pleads with Zeus and says, I want to be with my brother. I miss him. I love him. And Zeus, honoring his son's wishes, puts both Castor and Pollux in the sky as Gemini. But the more interesting story that I found, Castor and Pollux get a little bit of trouble. They run into another set of twins, and they are not related. I believe they are Idas and Lenurix. Do not quote me on pronunciation. But those are two twin boys, and they fall in love with two women named Phoebe and Hilaria, and they are engaged. But Castor and Pollux are like, hey, I like them. We're going to take them away from you, which obviously creates some drama. So when Castor and Pollux run away with their women, the other set of twins run after them and a fight breaks out. And eventually, Linnaeus, I'm going to go with Linnaeus, kills Castor. And of course, Pollux is upset and kills that brother. And eventually the other brother, Idas, is going to try to honor his brother now. It's the whole honoring brothers thing. And Zeus intervenes because he doesn't want his son Pollux to die and kills the last twin. And Pollux, of course, is now very upset that he doesn't have his brother. And again, pleads with Zeus, I want to be with my brother. I want to share my immortality with my brother. And Zeus again puts them both in the sky, which I think is really cute.
Yeah. Nice indeed.
So,
and I
very
think that Melanie might have a little bit of information about the objects they're holding here, but it was quite a dig to find out exactly why there's a harp, a club, and a bow and arrow.
It's very, yeah, because Castor is known for horseback riding and fencing. Those were his two amazing talents. He was really great with a sword. And Pollux was known for boxing. He was a boxing champion. And I actually think that Castor was taught swordsmanship and fencing from Hercules. So I'm very surprised that neither of those objects are with this picture. However, like Dana said, I believe Mel could give a little bit
She
more.
put some information there for us, so you can read more about it there.
Drama.
Always interesting things here. So this is like an old constellation card. You can see the stars there for Castor and Pollux, and just the descriptions around the stars and everything. There is Taurus here, and Auriga. There's other constellations, Lynx, Cancer, and then other ones we're going to get to eventually in this series, like Canis Minor and Monoceros. So there's
I
a
like
lot.
that this has those like those descriptors in there. That's really cool.
Yeah, I just love how ancient it kind of looks too, because this is a really old depiction, old graphic. So there's a lot more constellations to explore. But before we wrap up, Crow, do you have any final thoughts?
Not for me.
I could have talked a whole hour about Percy and the Mars rover. I had to like really go through it because I wanted to talk about its energy source and how it travels to Mars using the stars. So maybe we'll have to talk more about Mars someday, but it's a good thing that Percy is just starting out because it's going to collect a lot of information and we'll be able to talk about it for many months to come, I'm sure.
NASA does have a separate webpage that you can go to that is keeping up to date with that. They had a countdown clock and everything going on when it was first arriving there. So they're going to keep up with that. So those who are interested, feel free.
Yeah, maybe Mel can put a link to that NASA website in the chat for people. And there's a lot of websites, I'm sure, dedicated to Percy. But find the one that you like and keep it bookmarked so you can go back to it. It's going to be updated probably every day with new information and new pictures. There's also a really great Twitter account for adults for the Percy rover. So it kind of humanizes Percy and talks as if it is the rover. And it's quite enjoyable, but it is for an adult audience.
I do have a question. Are there any missions that are planned currently, or that are currently, traveling towards their intended objective?
Sorry, Caleb, you're cutting out just a little bit. So we're going to wrap up our conversation together with each other after we sign off today. And if we talk about anything interesting, we'll be sure to let you know when we come back. Next week, we're going to have the week off. So we're going to come back in March, later in March. So we'll see you then, everyone. For now, take care. Have a great evening and a peaceful, restful weekend.
Bye, guys.
Bye.